So we have to determine the middle term in the expansion of x minus 1 over x raised to the power of 10. So we begin by finding the middle term. So we have n is equals to 10, which is an even number. So we'll use the formula to find out the midterm value, which will be equals to n over 2, which is 10 over 2 plus 1, and that will give us the midterm. So we have 10 over 2 is 5, 5 plus 1 is 6, so the sixth term is going to be our midterm. So let's find out the value of t6, which is going to be equals to t5 plus 1, which is equals to 10c5 x raised to the power of 10 minus 5, which is going to be simply 5, times negative 1 over x raised to the power of 5. 10c5 has the value 252 times x raised to the power of 5, the x raised to the power of 5 times negative 1 raised to the power of 5 divided by x raised to the power of 5. The x raised to the power of 5 is common to both the numerator and the denominator, so they are going to factor out each other, and the final answer will be equals to negative 252. The negative comes because negative 1 raised to the power of 5 is negative 1. So that is going to be the middle term. Let's go to the next one. Now in this question we have to find out the middle term. Now the given binomial expression is 1 minus 2x plus x squared raised to the power of n. Now here we can't say if n is even or odd, but there's a smarter way to do this. We know that the expression 1 minus 2x plus x squared is actually an identity, which is equals to 1 minus x whole squared. So that means we can write 1 minus 2x plus x squared as 1 minus x whole squared raised to the power of n, which becomes equals to 1 minus x raised to the power of 2n. Now we know the 2n is an even number, so let's find out the middle term. So the middle term is going to be equal to 2n over 2 plus 1th term. So that's going to be equals to n plus 1th term. So our n plus 1th term is going to be the middle term. So let's find out the value of t n plus 1, which is equals to 2ncn. The first term is now going to be 1 raised to the power of 2n minus n, which is simply n, times negative x raised to the power of n. Now we open up 2n, so this becomes 2n factorial divided by n factorial times 2n minus n gives us an n factorial. 1 raised to the power of n is always 1. We pull out the negative number, which is negative 1 raised to the power of n times x raised to the power of n. So further simplification, we get 2n factorial divided by n factorial. It's getting multiplied to itself twice, so we write it as n factorial squared times negative 1 raised to the power of n times, so this is going to be the coefficient of the middle term, and the term to find out the term, we multiply it by the remaining variable, which is x raised to the power of n. Let's go to the next one. In this particular question, so we are given a polynomial expression 1 plus 3x squared plus x cubed raised to the power, I made a mistake here, this is 2n. It has to be 2n. Then we have to find out the middle term. So what we can do, we can use the identity a plus b whole cubed is equals to a cubed plus 3 times a squared b plus 3 times ab squared plus b cubed. What we're going to do, we're going to replace a by 1 and b by x, and that should give us 1 plus x whole cube is equals to 1 cube. That's going to give us 1 plus 3 times 1 squared times x is going to give us thrice x. Then for the third term, we have 3 times 1 times x squared, so which will be thrice x squared plus x cubed. So this is the polynomial expression, which can be simplified or in a condensed form can be written as 1 plus x raised to the power of 3. Now we replace this polynomial expression by this identity, then that should give us 1 plus x raised to the power of 3 whole raised to the power of 2n. So that should give us 1 plus x raised to the power of 6n, and this becomes a binomial expression. And now we have to find out the middle term. So we know the middle term will be equals to, the middle term is equals to 6n over 2 plus 1th term. So 6n over 2 is going to give us thrice n. 6n over 2 is going to give us 4n. Oops, really sorry, that's going to give us thrice n plus 1. So this is the term that we're looking for. So now we have to find out t thrice n plus 1, which is equals to 6n c thrice n. The first term is 1, which is 1 raised to the power of 6n minus 3n, gives us thrice n times positive x raised to the power of 3n. 6n factorial over thrice n factorial times thrice n factorial. 1 raised to the power of 3n is simply 1, and then we have x raised to the power of 3n. And the final answer will be 6n factorial divided by 3n factorial whole squared times x raised to the power of 3n. So this is going to be the middle term for the given expression. In this question, we're given a binomial expression, and then we have to find the middle term. So we start by figuring out if n is odd or even. So n is equals to 9, which is an odd number. So for odd cases, the middle term will be given by, the midterm will be equals to n plus 1 over 2th term and n plus 1 over 2 plus 1th term. So 9 plus in this particular question, we are given a binomial expression and we have to find the middle terms. Now we'll start by looking at the value of n, which is 9. Now 9 being an odd number, the middle term will then become, the middle term will be equal to 9 plus 1 over 2th term and 9 plus 1 over 2 plus 1th term. So these are going to be the two terms of the given binomial expression. So 9 plus 1 is 10, so we have the 5th term and the 6th term. So that means we have to find out the value of t5 and t6. So t5 is equals to t4 plus 1, which is equals to 9c4 times the first term, which is twice x raised to the power of 9 minus 4, that gives 5, times negative x squared over 4 raised to the power 4. So this is equals to 9c4 times 2 raised to the power of 5 times x raised to the power of 5 times negative 1 raised to the power of 4 times x squared raised to the power of 4 will be x raised to the power of 2 times 4, which is 8, divided by, now we have 4 raised to the power of 4, so which we can rewrite as 2 squared raised to the power of 4. So we'll have 2 raised to the power of 8. Then we simplify these values and this should give us 9c4. Then we have x raised to the power of 5 plus 8 divided by 2 raised to the power of 8 minus 5, and negative 1 raised to the power of 4 is positive 1. So the final value will be 63 over 4 times x raised to the power 13. Use a calculator to get the value 63 over 4. Now we move on to find out the next term, which is t6. So t6 is going to be equals to t5 plus 1, which is equals to 9c5, the first term, twice x raised to the power of 9 minus 5, which is 4, times negative x squared over 4 raised to the power of 5, which is equals to 9c5 times 2 raised to the power of 4 times x raised to the power of 4 times negative 1 raised to the power of 5 times x squared raised to the power of 5 will be x raised to the power of 2 times 5, which is 10, divided by 4 raised to the power of 5. Now 4 can be rewritten as 2 squared, so we have 2 squared raised to the power of 5. With the 2 and 5, the exponents gets multiplied to give us 2 raised to the power 10, which is equals to 9c5 x raised to the power of 4 plus 10 times negative 1, and negative 1 raised to the power of 5 is simply negative 1, divided by 2 raised to the power 10 minus 4, which will give us finally negative 63 over 32. 63 over 32 times x raised to the power 14. So these are the two middle terms for the given binomial expression. Let's go to the next one. So we have this is the expansion. So we are given a binomial expression, and then we have to find out the middle terms. So first we check out the n is given as 2n plus 1. Now any number when multiplied by 2 converts it into an even number, and when we increment it by 1 unit, then it becomes an odd number. So that means our given n index is an odd number. That being said, so we'll find out the middle term. So the middle term must be 2n plus 1 plus 1 over 2 with term, and 2n plus 1 plus 1 over 2 plus 1 must be the other term. So we'll solve for this. So 2n plus 2 over 2, so that leaves us with n plus 1th term and n plus 2th term. So these are the two terms which are going to be in the middle of the expansion of the given binomial expression. So let's try to find out the value of t n plus 1 first, which is simply equals to 2n plus 1 c n times x raised to the power 2n plus 1 minus 9 times the second term, which is negative 1 over x raised to the power of n. So we write it down as 2n, let's keep it as 2n plus 1 cn. So x raised to the power of 2n plus 1 minus of 9 is going to give us x raised to the power of n plus 1, negative 1 raised to the power of n time divided by x raised to the power of n. Further simplification gives us 2n plus 1 cn x raised to the power of n plus 1. We subtract the exponent of x in the denominator from that of the exponent of x in the numerator. So we'll have n plus 1 minus n divided by x raised, this has been taken care of, times negative 1 raised to the power of n. So our final answer is going to be 2n plus 1 cn negative 1 raised to the power of n times x raised to the power of 1. So this is the n plus 1th term. Let's go and find out the value of the other term, which is t n plus 2. So we have 2n plus 1 c n plus 1. It's always 1 less than the term. So tn plus 1 cn plus 1 times x raised to the power of 2n plus 1 minus of n plus 1 times minus 1 over x raised to the power of n plus 1. This is equals to 2n plus 1 cn plus 1 times x raised to the power of 2n minus n is going to give us a single n. The plus 1 and minus 1 cancel out, so it leaves us with only x raised to n. So we'll have x raised to the power of n times negative 1 raised to the power of n plus 1 divided by x raised to the power of n plus 1. Now we take care of the exponents of x. So that should give us negative 1 raised to the power of n plus 1 divided by x raised to the power of n plus 1 minus n. What we did is we brought the exponent of x from the numerator to the denominator, so they get subtracted. And the final answer will be 2n plus 1 cn plus 1 times negative 1 raised to the power of n plus 1 times 1 over x. So this is the answer. Let's go to the next one. So here we have to find out the middle term and the expansion of the given binomial expression. So we have n equals to 8, which is odd, so the midterm should be 8 over 2 plus 1th term. So that's the 8 over 2 is 4, 4 plus 1 is 5, so the 5th term. So that is going to be the middle term. So we find out the value t5, which is simply equals to t 4 plus 1, which is equals to 8c4 times the first term, which is 4x over 3 raised to the power of 8 minus 4, which is 4, times negative 3y over 2 raised to the power 4, which is equals to 8c4. Now 4 can be also rewritten as 2 squared. So 2 squared raised to the power 4 is simply 2 raised to the power 2 times 4, which is 8, times x raised to the power 4 divided by 3 raised to the power 4. Then we have negative 1 raised to the power 4 times 3 raised to the power 4 times y raised to the power 4 divided by 2 raised to the power 4. Then we do the final manipulation, which is 8c4. We have 2 raised to the power of 8 minus 4 divided by okay, there's no division required here because 3 raised to the power 4 is present in both numerator and the denominator, so they're going to cancel out each other. Then we are left with negative 1 raised to the power 4, which is always positive 1, and the final variables, which are x raised to the power 4 times y raised to the power 4. So this value is equals to 8c4 times 2 raised to the power 4 times x raised to the power 4 times y raised to the power 4. And you can plug this value 8c4 into your calculator and then multiply it to 2 raised to the power 4, and that should give you 1120 x raised to the power 4 times y raised to the power 4. That's it. That is the answer. Let's move on to the next one. So in this question we have to prove that the middle term of the expansion of 1 plus x raised to the power of 2n is given by this value 1 times 3 times 5 up to 2n minus 1 divided by n factorial times 2 raised to the power n times x raised to the power of n. So we begin by first finding out which term is going to be the middle term. So we have n is 2n, so we know that this is going to be an even number because any number which when multiplied by 2 converts it into an even number. Then our middle term is going to be given by 2n plus 2 plus 1th term, so that's the n plus 1th term. So this is going to be the middle term. So now we find out the value of t n plus 1, which is equals to 2n cn. The first term is 1 raised to the power of 2n minus n, which gives us simply n, times x raised to the power n. Now 2n cn can be rewritten as 2n factorial divided by n factorial times n factorial times x raised to the power n. Now what we're going to do, we're going to expand 2n factorial, so that should be 2n times one term smaller than 2n will be 2n minus 1 The next term will be 2n minus 2 up to 3 to 1 divided by n factorial times n factorial times x raised to the power of n. And what we're going to do is we're going to write all the even terms together and the odd terms in a separate way. So what I mean to say, I'm going to write 2n. I'm going to write 2n, then 2n minus 2, then the next one will be 2n minus 4, dot dot dot, up to 4 and 2. I'm writing all the even terms together, the product of all the even terms together, and all the odd terms will be written separately. So we have the first odd term is 2n minus 1 times 2n minus 3. I need more space. 2n minus 3 dot 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 3 to 1 divided by n factorial times n factorial. The whole thing is multiplied to x raised to the power of n. Now what we're going to do is we're going to separate, we are going to factor out 2 from each of the elements. So we can write twice of n as 2 times n. Then we can write this one as 2 times n minus 1 times 2 times n minus 2, all up to 4 can be written as 2 times 2, and 2 can be written as 2 times 1. And this will let it be the way it is, the odd terms, 2n minus 1, 2n minus 3, up to 1. The whole thing is going to be divided by n factorial times n factorial. So we have n factorial times n factorial, and the entire thing is multiplied by x raised to the power of n. Now why we have done is, so we see that there are n number of 2's that are getting multiplied here. So that can be written as 2 raised to the power of n, and what it leaves behind will be now n minus 1, n minus 2, to 3 to 1, and we have the remaining odd terms, which is 2n minus 1 times 2n minus 3 and 3 and 1 times x raised to the power of n, and the whole thing is divided by n factorial times n factorial. Now if you look closely, this particular section 1, 2, 3 going up to n, this is actually n factorial. So what we can do, we can factor out n factorial. This is the n factorial from both the numerator and the denominator, and that leaves us with 2 raised to the power of n times x raised to the power of n times the odd terms, which will be 1, 3 up to 2n minus 3 and 2n minus 1, and the whole thing is divided by n factorial. So this is the tn plus 1, which is the middle term, in the expansion of 1 plus x raised to the power of 2n, and this was what we were asked to prove. So let's quickly have a look at the question. So this is the question. Let me pull it, let me pick this one up, copy and paste it here, and let's compare it. So yeah, so we have 2 raised to the power of n, that has been taken care of. X raised to the power, it's been taken care of. 1, 3, the remaining odd terms, divided by n factorial. So that is the middle term. So in this particular question, we are provided with 2 binomial expression. One is 1 plus alpha x raised to the power of 4, and the other one is 1 minus alpha x raised to the power 6. Now it's given here that the middle terms of both the expansion, the coefficients of the middle term are equal. Then using that information, we need to figure out what's the value of alpha is going to be. So let's do it one by one. We begin with the first expression, which is 1 plus alpha x raised to the power 4. So here we have n is equals to 4, which is even. So that would mean that the middle term is going to be given by 4 over 2, which is 2 plus 1th term. So 4 over 2 is 2, 2 plus 1 is 3. So we have the third term here. So that means we have to find out the value of t3. So that's equals to 4c2, 1 raised to the power of 4 minus 2 times the second term, which is alpha x raised to the power of 2. This is equals to 4c2 alpha squared x squared. The coefficient will be 4c2 alpha squared. Now we go to the next expression, which is 1 minus alpha x raised to the power 6. So here we have n equals to 6, which is again an even number. So the middle term will be 6 over 2 plus 1th term. So 6 over 2 is 3, and 3 plus 1 gives us 4. So we have the fourth term, and that will be the midterm. So we have t4, which is equals to 6c3. 1 raised to the power 6 minus 3 gives us 3. Then we have negative alpha x raised to the power 3, which is equals to 6c3 negative 1 raised to the power of 3 times alpha cubed times x cubed, which is equals to negative 6c3 times alpha cubed x cubed. So we have the middle term of both the two given expression. Now, according to the question, it said that the coefficient of the middle terms are equal. So that would mean the coefficient of the first expression is 4c2 alpha squared, and this must be equals to the coefficient of the middle term of the second expression, which is 6c3 alpha cubed. So let's try to find out the value of alpha. So 4c2 gives us the value. So this is 6 alpha squared equals to negative 20 alpha cubed, which will be equals to 20 alpha cubed plus 6 alpha squared equals to 0. Then we take alpha cubed squared common, 2 alpha squared common, which should give us 10 alpha plus 3 equals to 0. So that gives us either alpha is equals to 0, 2 alpha squared is equals to 0, which would give us alpha equals to 0, but that is trivial when we're going to reject this value, and the final value will be 10 alpha plus 3 equals to 0, and that gives us alpha is equals to negative 3 over 10. So we are going to reject this one and going to accept only one of the value, and that is negative 3 over 10.